the Practical Cloud 6th video. Now this is going to be a special video because in this video we are really going to be using cloud. No more of boring you with fundamentals. So let's get started. I'll open up my GCP Google Cloud Console page. As I said earlier, we'll be doing most of the practical part using GCP, but the concepts apply to all cloud service providers. I'll try to be as generic as possible, but as far as the implementation part goes, we'll be using GCP or Google Cloud. So let me open up my GCP project. We'll go to the console. By default, it opens up your default project. Okay, this might seem overwhelming. There's a lot of options. There's a huge navigation bar here, but bear with me for a few videos, you'll understand. We'll only be using a few of these, but hopefully you'll understand what most of these mean and what purpose they serve. There are two ways you can follow along this tutorial. One is link your credit card with Google Cloud and claim this free $300 credit. The other is what we had mentioned in our course registration form, that is using Quick Labs. Quick Labs is a great tool. It can set up mock cloud environments for you to practice. It includes not just GCP, I think it includes AWS as well. So if you are interested, you could try out different labs. In this video, we'll be hosting the same old LAMP stack which we did on PC, but now on cloud. So let's get started. You will see a navigation bar here. If you cannot, then just press here to open it up, and below here in the compute section, click on compute engine. Now, depending on how you are following along this course, mostly you will not be having any VMs running in your GCP project. So GCP will be prompting you to create a new one. But in my case, I already have 3 instances created, and one of them is running, which can be seen clearly by the tick mark, and the rest 2 are stopped. So we leave that as such. We'll create a new one. Let's name it instance PC lamp, and we leave the default region, default zone. I'll take an F1 micro, that's sufficient. Oh right, I didn't explain what Google Compute Engine is, right? So this is a virtual machine. If you're not sure what virtual machine is, I would suggest that you Google it up. Speaking in layman terms, this would be like a PC, but it will be without monitor and it will be connected via the internet for you to access. A lot of things can be achieved this way. What would you look for when you're buying a laptop or a PC? You will look at the specs, right? You will see what is the processor's generation, architecture, what is its clock speed, how many threads it has, how many cores it has, and does it support hyperthreading, does it have virtualization, etc. So, and also you will be looking into other aspects such as hard disk or SSD, that is storage space, and even RAM, right, system memory. How many gigabytes of memory the system has in RAM, as in RAM space. So in this compute engine, you can choose what configuration you need. So I have an by default it was this N1 standard one, which is 1 vCPU. For simplicity, consider 1 vCPU as 1 core of CPU. It may not be exactly true, but it is an easier way to compare. I think all of us are used to listening how many cores of CPU we have, right? even your smartphones nowadays have octa-cores of 8 cores or octa-core CPUs. So, and our desktops probably have 6 or 8 cores. Similarly, this one CPU is kind of equivalent to a one core, a single core CPU, and V here stands for virtual CPU. So vCPU, in vCPU the V stands for virtual, so it's virtual CPU, and it's 3.75 GB of memory RAM. This is not the hard disk or storage space, this is just the RAM memory. We don't need this high of a configuration. Yes, this is not such high configuration, but for a simple task such as serving hello world website, we can do with this shared core. And I think I'll leave the shared core concept. I'll not explain the shared core concept to prevent further confusion, or maybe in some other video I'll try to explain what this means. And in the meantime, if you're curious, you can also you can try googling it. So I think for now, one vCPU with 614 MB of RAM is more than sufficient for us. I'll use that. Remember, as we change this, we have an estimate change. Now for an F1 micro, I get a $4.28 monthly estimate if I run the system 24 hours of a day, 7 days a week. But if I choose an N1 standard one, which is a higher configuration system, then that increases the price, right? Obviously. If we just scroll down, just for curiosity, in this series, in this N1 series, the highest machine configuration has 160 vCPUs and 3.75 terabytes of memory. Now, you may ask, who uses these, right? There are a handful of people who require these kind of configurations, but today it's not going to be us. So we'll stick to the F1 micro. And okay, so boot disk, we leave the default 10 GB standard persistent disk, and we'll also leave the default Debian Linux OS. Okay, we'll allow HTTP traffic, and we'll click on create. We need this because we need to be able to access our website, so for that we need HTTP. Let's click on create. It's creating. It's still creating. It took about 10 to 15 seconds for this instance to be created. Now the instance is successfully running. Let's SSH into it. Now SSH stands for secure shell. Remember when we did the LAMP stack on Linux part? If you watched that video, you will know that almost every task we did was using the Linux terminal. Similarly, here all we have access to is a terminal. That is what the secure shell brings us. Shell is a terminal, and secure is because it's secure. Even here, this is the only way as of now to access your one shared vCPU 614 MB computer that is somewhere in Google's network. And I think we had it in US. Some region is US. Yes, we had it in US Central region. Okay, so let's get started. We'll first install Apache. That is what we need to serve the website, right? Sudo apt get update. We'll update the apt package. Sudo apt get install Apache 2. You want to continue? Yes, I want to. Okay, we are done installing Apache 2. Now let's just start it. Okay, let's just start the Apache 2 and see whether the default website works. We'll use sudo systemctl apache restart start Apache 2. I think we are good to go. Let's click on this external IP link, and yeah, it works. It says it clearly, it works. Great. So far so good. Now all we need to do is copy our old code, which I have it here on my PC. Remember this code? This is the same code that we used in the lamp stack on PC video. Let's copy it and have it in our clipboard. We'll switch back to our terminal and let's change our directory to the directory of the Apache 2 serving place. I think it's yes, HTML. This index.html is a website being served. Let's remove it. Okay, now this index.html was this website, and we can safely remove it. We don't need it anymore. Now in that place, we'll create an index.php file, and now in that we'll be pasting the code which we had copied into our clipboard. Control V, and that's it. We can write it out and exit the file, and I think we should be good to go. Let's restart this. Aha, okay. For the most part, the website seems to be working, but there is a small glitch. PHP. The PHP part is not running. Let's try to fix this. Okay, so the only package that we're missing right now is PHP, and if we install PHP, we should be good to go. Sudo apt get install PHP, and that's it. We should be good to go. Let's check our website, and that's working. Remember, we got a PHP printed as such, the PHP code being printed as such, and now we have Linux over here, which is how it should have been in the first place. So it's working. This is Hello World from Linux. Cool, isn't it? Now you can share this IP address to your friends and ask them to open it on their browsers, and even they will be able to see this website. Awesome, right? You could go a step further and buy a domain name such as www.yourname.com and connect it up to this IP address such that whenever your friend types in that domain name, it connects to your compute engine, which will be serving the website you have designed. And those of you who are doing it at your own expense, having linked the billing account and using the trial, do not forget to stop or delete the instance as and when you're done with it. Otherwise you might get charged unnecessarily. Now this F1 Micro is an inexpensive little VM, and even if it runs 24/7, it wouldn't cost you much, but it's always a good practice to keep a track of what's going on, what's running and what's not, and stop everything, every service as and when you're done with it. Remember, you're on a cloud, so you can restart and recreate anytime. For example, let's say you thought you're done with it and deleted it, as in this case, as I'm done with it, and a minute or two later you realize you had actually planned to try out one more example. Then you may just go ahead and click on create instance and proceed. It will take you what, 15 seconds to create an instance. Now that is the power of cloud. And remember, it takes just 10 to 15 seconds usually to create a VM, but it takes a little longer than that to delete one, as you might see in this case. See, it's been more than 15 to 20 seconds since I pressed delete, and this instance is still being deleted. Still hasn't been deleted completely. So that's it for this video. As always, follow us on Twitter, and if you have any questions, we'd be glad to help you out.